Okay, so we're going to go ahead and finish up the end of 3.3. So in your packet, you had these graphs right here that had the derivatives of inverse trig functions on the bottom. So it's number 3. We already used this graph right here, so now we're going to use this one right here. Okay. All right. You're also going to go ahead and put this down in your notes as I get this ready here. And so we're looking at an important concept that we'll use in a lot of different contexts, not just doing implicit differentiation. Okay, so hopefully this video works out. I think it has a little bit of a lag because I'm using my camera at home. Okay, so the main thing that we want to see is we're looking for horizontal or vertical tangents here. And they kind of have an idea that we use over and over again, that if something has a horizontal tangent, it has a slope of 0, versus if the tangent's undefined, then the derivative or the slope is undefined. So that's the main concept that I want you to get from this whole thing, that you can use that later on. Okay, so let's go through how we go about doing these. Okay, the first thing that you're going to do is you're going to find the slope. Okay, so we've been doing these implicit differentiation problems, so this should be okay. Okay, we know right here that we have the product rule going on. So I'm going to write the first derivative of the second plus the second derivative of the first. Derivative of a constant is 0. Oops, I forgot to do y squared. Okay, so that's going to be 2y dy dx. Okay, so I'm going to do this kind of all in one shot here. I'm going to say dy dx times x plus 2y is equal to negative y minus 2x Okay, so now here comes the main part that I want you to know. Okay, if we want the horizontal tangent, then we know that the slope has to equal 0. Okay. Now I want you to think about what happens when you set a rational function equal to 0. Sometimes people memorize that all you do is you set the top equal to 0. But instead of, again, we don't want to memorize little things that don't make sense to us. I want you to think about if I wrote it like that, and that we just cross multiplied. And I said this times that equals this times that. We'll see how the bottom would equal 0, and we would just get that negative y minus 2x equals 0. Okay, which is going to tell us that y is equal to negative 2x. Okay, now let's look at the vertical tangent. and the derivative does not exist, or it's undefined, however you want to say it. So it just equals some number over 0. Okay, that's the key thing right there. So we don't really care about what the top equals. We only care that the bottom, that x plus 2y, is equal to 0. Okay, so now I'm going to substitute these into the original function. Okay, so let's go ahead and do that. Okay, so here was the original function. So x squared plus xy plus y squared is equal to 27. So x squared okay. Okay, so this gives me the x values for where I should be able to get a horizontal tangent. Okay, I would plug these back in to the original function and find the y values. So you can go ahead and do that, but I'm going to tell you that it's going to be at 3, -6. And you might want to make yourself a note, if you didn't do that, on how we got those other values. Okay, so let's see where this is on here. Okay, so 3, 1, 2, 3, 4, 5, 6. That's looking good. 3 or -3, 6. Oops, I just did that. 3, -6, right here. Okay, so it didn't ask for an equation or anything like that. It just said, where are those values at? Okay, let me see if I have a ruler around here somewhere. I do. So I can see. Well, that didn't work out very well. Let me try a different color. There's one there. That still didn't work out very well. And one there. Okay, so it's nice to have the figure because we can see that we've done it right. Okay, let's look over at this one right here. So we're going to do the same thing, but we're going to plug in -1/2 x for y. Okay, so let's see, over here, this is going to end up and x squared will equal 27 oops, 3 goes in here 9 times, not 3. Okay, and there is our plus or minus 6. Again, I would plug those back in to the original equation up here, and I would get the y values. Okay, let's see if this is going to work. Okay, so I'm going to look at the point 6, -3. So 1, 2, 3 right there. That looks good. And the point -6, 1, 2, 3 right there. Okay, so again, the main thing that I want you to note from this, more so than just that we're doing implicit differentiation, is how do you find a horizontal tangent and how do you find a vertical tangent? Okay, so then what I want you to do is I want you to go back to the worksheet that we did on 3.3, and I want you guys to do number 14, okay, and let's go ahead and do 12. Okay, so 12 and 14. All right, that's it.